What are the key components of an LLM architecture, and how have you trained LLM in the past? Large language models (LLM) have revolutionized the field of natural language processing by enabling machines to understand and generate human-like language. To train LLM, researchers and developers employ a combination of techniques and architectures. In the past, I have trained LLM using a variety of approaches, including supervised learning, unsupervised learning, and reinforcement learning. One of the key components of an LLM architecture is the attention mechanism. This mechanism allows the model to focus on specific parts of the input sequence, such as words or phrases, and weigh their importance in the overall context. This is particularly useful for tasks that require understanding complex relationships between words, such as language translation, question answering, and text summarization. Another crucial component is the dataset used for training. LLM are typically trained on massive datasets of text, which can range from a few million to billions of words. These datasets are often sourced from the internet, books, and other written materials. The quality and diversity of the dataset play a significant role in determining the model's performance and ability to generalize the new, unseen data. Deep learning neural networks are also a fundamental component of LLM architectures. These networks are designed to learn complex patterns and relationships in the data by processing it in multiple layers. Each layer builds upon the previous one, allowing the model to capture increasingly abstract and nuanced features of the input data. Transformer models are a specific type of neural network architecture that has gained popularity in recent years. They are particularly well suited for LLM due to their ability to handle sequential data such as text and their parallelization capabilities, which enable efficient training on large datasets. In addition to these key components, other important factors that contribute to the success of LLM include the choice of optimizer, learning rate, and hyperparameters. These factors can significantly impact the model's performance, and careful tuning is often required to achieve optimal results. In summary, training LLM involves a combination of techniques, including attention mechanisms, large data sets, deep learning neural networks, transformer models, and careful hyperparameter tuning. By understanding these components and how they interact, researchers and developers can design and train LLM that are capable of achieving state-of-the-art results in a wide range of natural language processing tasks.